In our last lesson, we started looking at solving quadratics. Today, we're going to take a deeper dive into that because not all quadratics can be solved, and sometimes it's helpful to recognize how many solutions you could possibly have before you even start the problem. For instance, if you can't solve it, why bother trying? So, take a look at the screen right here. Here's the three possible quadratic types of functions. Okay, we could have two zeros. That's been our typical question all along. Okay, we call these things roots also, and we'll explain why in just a minute. Okay, we can also call them x-intercepts or solutions. We could have one zero. That means your vertex is your zero. But there are also situations where you don't even cross the x-axis, you don't have zeros, which means you can't actually solve that quadratic. Okay, now, of course, these pictures could be upside down, right side up. That part doesn't really make a difference. It's more about the general idea of how many solutions you may have. Okay, so big ideas. If it has no roots, don't worry about solving it. Can't be solved. Single root, that means the solution is the zero. And two roots or two solutions, both of which might be possible, or we may come across some situations down the road that we may call inadmissible. Mathematically they work, but practically they don't make sense. Okay, how do we figure this out? Well, it depends on what form it's given to you. If it's given to you in factored form, which is the first form we started with, you can literally look at the question and say to yourself, hey, I know how many zeros it has, because I absolutely positively know what the zeros are. There's one there and there's one there. It's negative 1, 0, and it's 2, 0. It's got two roots or solutions. Or you could have an equation that looks like this. A perfect square, the same zero twice. Well, if it's the same zero twice, it only has one zero, one solution, one root. And it's not possible to have no solutions, because then you couldn't have factored form. Factored form is literally the roots, right? The solutions, the zeros. So that's the easiest form. We like that form. Okay. You take a look at the next two. You tell me, how many roots do these things have? Should be real quick. Look at it, tell me. I think this one has 2. I can see what they are, 3 and negative 5. I think this one has 1, the same root twice. Hey, that's it. You can look at them and tell. There's no tricks to this. But if they're in standard form, like usual, standard form is not the best form, it's just the standard form, you can't just look at it. You actually have to do a little bit of math. So like we had a formula for AOS, we have a formula for how many roots it has. Okay, it's called the discriminant. Discrimination is usually bad, but in this case it's good because it's going to tell us how many answers we have. To find the discriminant, you calculate b squared minus 4ac, where a, b, and c come from our typical standard form locations. So you kind of want it in the right order before you start. And then you take your number and you examine what kind of value you got. If you get a positive discriminant, that means there's 2 roots, 2 zeros, 2 solutions. If you get exactly 0, there's only one single thing, one single solution. Your vertex is your 0. And if you end up with a negative number, that means there are no solutions, there's no roots. So we're going to try a few of these to get the hang of this. Okay, so this is an equation. We're looking for a number of real roots. It's in standard form. So here's my A, my B, my C. My discriminant says, take your B, which is negative 4, and square it. Be careful with your signs, right? We always want to put the sign inside the bracket. Minus 4 times A times C. It's all stuck together here, so multiply it all together. Okay, get out your handy dandy calculator, type it all in. We end up with negative 32. The part that's important is the negative sign. Yeah, I want you to have the right number, but the negative sign is the important part. If it's negative, what do we say up here? There will be no roots, no solutions. Okay. Negative 2, negative 32, negative 502. It doesn't matter the fact that it's negative. That's important to us. Okay, maybe you got the hang of it. Try the next one yourself. If you think you do, pause it, try it. We're going to do the exact same thing. We're going to discriminate. So b squared minus 4 times a times c. We can get, what's that? Typed in our calculators. And I got exactly 0. What does that mean? Well, from our list up above, exactly 0 tells me I have a single 1 root. Okay. And last one here, discriminant is b squared. So I got a 7 minus 4 times a is the number 1 in front of our x squared times c. Now notice there's no number over here. That makes c 0. Technically, the only thing you have to have for a quadratic is an a value. You could be missing b or c. So I get 49. The fact that it's actually a positive 49 tells me there are 2 roots. Okay. Not a hard calculation, a pretty quick one, but helpful for us. Okay, what can we do with this stuff? Well, it allows us to check if problems are solvable. If they're not solvable, we're not going to waste our time trying to solve them. If they are solvable, we know how many answers we should get. So, our example here says use the discriminant to determine the number of solutions each equation has. Well, to use discriminant, we need standard form. So job 1 is always put things in the right order. Standard form means my squared term wants to go first. My x term wants to go second. But I need to bring these over here so it equals 0 and is in the right order. We're going to collect our like terms. So -5 and -3 makes -8. And now I'm ready to see if this is solvable. Today, I don't care what the solutions are. I just care, is there solutions? So discriminant says b squared minus 4 times a times c. Okay, 64 and 16 makes 80. Ooh, that's a positive number. How many solutions does this have? 2. Positive discriminant means 2 solutions. Okay, you guys try the next one. We're going to expand our brackets. 4x squared plus 8x. We're going to bring things over to the other side because I need to make it equal 0. Do the opposite operation. All right, 4x squared and 5x and 10. Standard form equal to 0. Job 1. Okay, let's discriminate here. b squared minus 4 times a times c. What's that? 25 minus 160. Negative 135. Notice I made the negative really big because this has no solutions. This is a question I would not be able to solve. And just to point out to us what's actually going on here, you have some sort of quadratic, maybe it looks like this. You have some sort of line that maybe looks like this. We want to know where they equal each other. Well, they never equal each other. The line never touches the curve, which is the reason there's no solutions. They don't actually meet each other. Okay, let's move on to some little word problems here. Typical money problem. We've done this a few times. Studies have shown that 500 people attend a high school basketball game when the admission price is $2. It sounds like a typical money question to me. So my revenue is, okay, we have 500 people and we have $2. That would make us $1,000. But we're going to increase our prices. For every 10-cent increase, so every time we go up 10 cents, we lose 2 people. And again, we don't know how many times we do this, so x is always the number of changes. Okay, what do they want us to figure out? To break even, they need to bring in $2,500. Is it possible to break even? So my revenue has to be at least that much. So I'm going to put $2,500 on this side. And the question doesn't say what do I have to charge? It says, is it possible? So really I'm checking, can I solve this? So my next job is, I'm going to put this in standard form, which means I need to FOIL. 500 times 2 is 1,000. 500 times 0.1 is 50x. 2 times 2 is 4x. And minus 0.2x squared. Okay, I'm going to put it in the right order and make it equal 0. So my squared term is going to go first. I'm going to collect my x's. It's going to be 46. I have my 1,000. But I have to bring this 2,500 to the other side. So how about minus 2,500? And then if I collect those numbers, I have standard form and equal to 0. Let's move this down a little bit here. Okay, we want to know, is it possible? Well, let's check out our discriminant. 46 squared minus 4 times a times c. And your calculator for this one, 46 squared minus 4 times 2 times 1,500. Be careful with all your signs. Signs are super important. I got 916, which is a positive number, which suggests to me it can solve this. So the question is, was it possible to break even? Solve. That's some good spelling there. Let's put that as a V. Solvable. So therefore, it is possible to break even. And that's all the question asks us for. It doesn't say what price to charge, doesn't say how many people. It just says, is it possible? Okay, you guys are going to try one. The height of a trampoline jumper in meters can be modeled by this equation, where t is the time in seconds. Do they reach a height of 6 meters? Well, h is my height. I'm going to put 6 in there. I'm going to say to myself, okay, I have this equation. I want to know, is it possible to solve this? Well, I can figure that out by making it equal to 0. I'm going to bring that 6 to the other side and subtract it. That gives me negative 4.003. This would be a pain to solve, but good news is I don't have to solve it. I just have to check, is it possible? Does it happen? That's discrimination again. B squared minus 4 times A times C. This one we're going to have to be careful with our decimals and our signs. All those things come into play. And I got negative 13.5843. What does that mean? Well, the number's not super important, but that sign is. This has no solutions. What does that mean in our case? Can't solve this problem. The jumper does not reach 6 meters. In fact, I'm sure we could actually figure out the vertex if we needed to figure out how high they got. It just didn't ask us to do that. Just ask us, can we solve this problem? Okay, that's it. That's all. We're done for today. Here's some practice questions. We'll try to sheet off the website. If you're stuck, come see me. Send me a question.